Welcome to Study Loop.
Okay, so we are given a question that spring has mass m, spring constant k, and damping coefficient is so small that it is nearly equals to 0. Also, we are told to assume omega is root k by m and it's a forced vibration, so f is f naught cos omega naught t. Okay, and we need to find the solution. So we know general equation is m times, let's assume y is the displacement, so m times y double dash plus c times y dash plus ky equals to the force, that is f naught cos omega naught t. Okay, now since c is nearly equals to 0, we can write this as m y double dash plus ky equals to f naught cos omega naught t. Okay, so we can find the solution. It has two solutions, or we can divide the solution in two parts. One is general solution and one is particular solution. Okay, or we call it as complementary solution. Okay, so first we can write this as my double dash plus ky equals to 0. This is a complementary solution. And we'll have particular solution, that is yp equals to, now since we have this function here cos, so we can write our solution yp as a sine omega naught t plus b cos omega naught t, and we'll see what the value of a and b we get after solving this. So for this complementary solution, we know if we replace and write it auxiliary equation, we'll get mr square plus k is equals to 0. This is our auxiliary equation, and solving for r we get plus minus root k by m I, which is nothing but plus minus omega I. So therefore the solution is, that is one part of the solution, complementary solution, is y equals to c1 cos omega t plus c2 sin omega t. Now we'll solve the particular solution. So we have yp as this. So if we differentiate this, so we'll get a times omega naught, sine differentiation is cos omega naught t, and differentiation of omega naught is omega. Okay, similarly here we'll have b omega naught sine omega naught t, but differentiation of cos is minus sine, so this will become minus. Okay, so we have to differentiate it again since our equation requires 2 times. So this becomes a omega naught square, cos differentiation is minus sine omega naught t plus minus minus b, and again when we differentiate sine we get cos omega naught t, and then differentiation of omega naught t is omega, so we'll have omega naught square. The same process is applied here. So now we have it, we'll substitute in here. So what we'll have, so let me divide this. Okay, so we'll get m times y, that is particular, if we have the solution, so we'll substitute here minus omega naught sine omega naught b minus b times omega naught cos omega naught t plus k times, so plus k times yp, which is a times sine omega naught plus b times cos omega naught t, which is equals to f naught cos omega naught t. Now since we have cos here, so we'll separate this equation in terms of cos and sine. So we'll write first cos term. So here we have cos, so we will multiply m, so we'll get minus mb omega naught square cos, and from here we get, after multiplying k, plus kb, and cos omega naught t is the common term. Similarly, second term is sine, so we'll get minus ma omega naught square, and from here plus ka sine omega naught t. Great. And this is equals to f naught cos omega naught t. Okay, so on comparing the left and right hand side, what we get is minus m b omega naught square plus kb is equals to f naught, and since we don't have sign here, so this term must be 0. So minus ma omega naught square plus ka is equals to 0. So solving this, we get what? If we take b common, so we get k minus m omega naught square is f naught, and therefore b is f naught over k minus m omega naught square. Okay, so if we take m out in denominator, so we'll get k by m minus omega naught square, and we know k by m is what? Omega square. So this becomes m times omega square minus omega naught square. So this is value of b, and from here if we take a common, we get k minus m omega naught square equals to 0. We know this cannot be 0, otherwise this term will become infinity, so a must be 0. Okay, so a particular solution will be yp is b, which is f naught over m omega square omega naught square times cos omega naught t. Great, since a part is 0. So total solution is y. So y, that is a total solution, is complementary plus particular. So what was the complementary solution? Complementary solution is c1 cos omega t plus c2 sine omega t, and yp is f naught over m times omega square omega naught square cos omega naught t. So that's a final solution. Thank you.